Hi, my name's Darren Mulvenna and I'm presenting Inventory Level Optimization powered by Artificial Intelligence. So when managing an inventory, there are problems that are generally not unique that we have to face. So things like our inventory value keeps going up, but there are more stock outs. Lead times are not accurate. There's warehouse inefficiencies, poor inventory accuracy. So we need an inventory optimization tool to help right-size your inventory, improve your parts availability, and reduce the operating costs. So within a mining operation, we have assets, and then we have very expensive parts, often called components, that support those assets. These are generally managed manually, things like buckets, ropes for drag lines, bucket teeth, etc. On the right here, we see our maintenance, repair, and operation spare parts. So this is everything from piece parts designed to go with those components to light vehicle parts, electrical parts, plumbing, tools, pumps, the PPE that maintenance guys wear, down to everything to office computers and to the coffee that the guys drink in the crew room. So all these parts need to be stocked or need to be catalogued so we know what they are. So within an ERP system, we have what we call a parts catalogue or a material master. So it has information in there. So against each stock item or part, we have a description. We have a group. So a grouping is it tools, is it PPE, is it consumables. We have unit price, stock in hand, unit of measure. There's a whole lot of other information against each of these stock items. But the two most important values are the minimum and the maximum values. So this min and max are the reorder values. So they're important because they drive investment in your inventory and they drive parts availability. So your min-max. So your minimum, when do I order? So the min value represents a stock level that triggers an order, whereas a maximum is how much do I order. So the max value represents a new targeted stock level following the reorder. So the difference between the min and the max is your reorder quantity. So in this example, if you have a minimum of 5, ordering up to a maximum of 10, and your reorder quantity is 5. So how are these min-max set in your ERP system? Well, a lot of times it's guesswork, gut feel, maintenance suggestions that are not that accurate. There are ERP systems that contain some reorder algorithms, but often they just use static values. So an example of that is something like the lead time. So within the optimization system, it calculates an actual average lead time based on the purchase orders and the receipt dates of those purchase orders. So it can work that out into days, and it looks at all those days and works out an average. So it's dynamic in the sense that as orders, transactions get added to this, it recalculates that lead time, which is very valuable in the calculation of the min-max. So when you're managing thousands of items, you need efficient procedures and tools. It's hard to do it manually, and it's not a one-off exercise. So it's an ongoing exercise because demand can change. It can go up, it can go down, and then you can be left overstocked or you can be left understocked. So it's generally a monthly review activity. So your minimum, when to order. So some considerations. So how long does it take us to get the stock? What's the supplier lead time? Secondly, how much will we use while we're waiting for that new stock, replenishment stock, to arrive in the warehouse? So we call that our lead time demand. Third consideration is how critical is the stock? What's the impact on the business if we don't have that part or that stock when we need it? So when we look at our lead time, there's variability in our lead time. One month it may take 5 days, the next month it might take 10 days. And again, there's also variability in that lead time demand, so how much we use while we're waiting for the lead time. So because of that, we need to hold safety stock. So our minimum is calculated by our lead time demand plus our safety stock. So if we look at the sawtooth diagram here, it shows the replenishment cycle. So the red line's the replenishment cycle. So you can see in a perfect world where the lead time doesn't change, you hit your minimum, you use a little bit of your stock, and you've replenished before you run out. If that lead time blows out, you can see that you'll use all the stock that you have on hand, and you'll stock out. Again, it may not be that your lead time is long. It may be that your demand during that lead time has increased, which again leads to a stock out situation. So your minimum directly relates to service level and parts availability. So if we can improve that service level, we can reduce stock outs and we can reduce downtime. So our maximum is our minimum plus the economic order quantity. So how do we come up with the economic order quantity? It's a balance between our purchasing costs and our holding and carrying costs. So our purchasing costs are the cost to send the order, to expedite, to receive the goods, pay the invoice. Our holding costs are warehouse costs, racking costs, resources to do cycle counts, obsolescence, losses, etc. So if we look at the left here, it's a visual of the balance between the purchasing costs and the holding costs. So you can see where they meet. The total costs, that's the economic order quantity. So on the table on the right, this particular stock item, it has a unit price of $10. It's got an annual usage of 120. The purchase order line cost is $20, and the holding cost is 20%. So if you look at the top line there, if we have an order quantity of 10, we're doing 12 orders a year. That's costing us $240 in purchasing costs. Our holding costs are low. They're only $10 because we're purchasing it all the time. So our total cost is $250. If we go to the next line down, you can see if we go to order quantity of 20, we halve our purchase orders. So our purchase costs come down to $120, and our holding costs go up to $20. Then we look at the total cost of $140. So you can see as we continue to go down to the red line there, that's where it meets our economic order quantity. So when we order 50, our purchasing costs are $48, our holding cost is $50, and the total cost is $98. So that's the economic order quantity. And then you see as the order quantities start to rise after that, the total cost value goes up. So there is an economic quantity which is financially best to purchase. So the maximum, in some circumstances, your max value will be determined by things other than the economic order quantity. Things like vendor lot size. A supplier or vendor may have a minimum order quantity. Space in your warehouse, safety. You can only store a certain amount of gas bottles in one area for safety. Things like shelf life. So the maximum value impacts the average stock level of each item and therefore affects the holding and carrying costs associated with storing and managing the inventory. So again, just to reiterate, your minimum is when do I order? It drives service level and parts availability. Maximum, how much do I order? It's your investment in your inventory and investment in carrying costs. So if we're going to use that inventory optimization system, we need to extract data from the ERP. So what we need to pull is a parts catalog, so that the area that has all the stock items, all the information on the stock items, including the current min-max values. We pull the vendor and supplier information. We pull all the purchase order and receipt history, and we pull all the usage history. We suck that into our optimization tool. We use a whole lot of rules, which I'll go into in a minute, to then produce a inventory, dynamically optimized minimum and maximum, which is then fed back into your transactional ERP system, and that affects your improvements in service level and reductions in inventory value. So as the data comes into our optimization system, firstly, there's item classification. So if a stock item in your ERP system is classed as a repairable item, then it's classed as a repairable item in the optimization system. If it's an insurance item, it receives that same classification. So once it goes through and it classifies those as like for like within the ERP system, what you're left with is just the items that are not classified as anything, but they're just active. So they're moving. Some are moving fast, some are moving medium, some are moving slow. So they're classified into classes that identify if they're a high usage value, the number of times they get issued annually. And we then use that to go on number 2 there to set service levels. So those classifications can have service level targets put against them that we want those to meet. 3 there, we have the lead time. That's where it looks at the purchase orders and receipts and comes up with that average lead time. It also applies some factors with regards to the artificial intelligence for demand management and forecasting. Again, that's where our artificial intelligence kicks in with regards to algorithms, and that's then used to calculate our min-max. We also identify surplus stock, how long it's going to take for that to run down, and all this information is presented to us in 7, 8, and 9, which is BI dashboard type information, so we can monitor what benefit we're getting from our review activity, as well as sort of monthly reports showing our inventory ups and downs, etc. So artificial intelligence. So IMAFS improves our future. Artificial intelligence improves our future lead time forecasts. It also benefits us in our forecasting. So there's a 20% decrease in forecasting error rates when we use the artificial intelligence benefits. And this can correlate to a 20% decrease in the amount of safety stock that we need to hold. So the forecasting process, number 1, is we pull the data in and we cleanse it. We remove anomalies, we determine seasonality, etc. Then our forecast generation. So this is where the artificial intelligence kicks in. Looks at a whole lot of different algorithms and then goes to the 3, which is a forecast error calculation. So it's the mean absolute deviation between forecasts and the real demand of the last 6 months. Then the final stage, 4, is it chooses the best forecast algorithm method. And that method can change each month based on the data. So, this is the artificial intelligence, is that the data is driving the decision making from the optimization system. So that algorithm can change month on month depending on what the data is telling the system. So time series forecasting. So time series forecasting is an important area of machine learning because there's so many prediction problems that involve a time component. So this time series forecasting, it looks for patterns and eventually spans them over longer sequences. So ideal for identifying these different usage traits such as seasonal, etc. So if you have a part it slowly starts to identify that it's seasonal, what it will do is it will increase its minimum at that point in time that it needs to ramp up. Then it will lower it when understanding that seasonal trend when that ends. So it's very dynamic in that sense. So again, the process, we've taken out the transactional system, we've applied all these parameters, artificial intelligence, and we then feed that optimized min-max back into the ERP system. So we have BI dashboard reporting. As I mentioned, this is essential because you want to see the benefits of the work that you're doing through pulling these parts in and optimizing and then sending those back. So a good BI dashboard reporting tool should provide plenty of filters, so you can filter on different parts, on the different classes, and review that information going forward. So when we look at our inventory challenges, we look at our poor inventory accuracy or the warehouse inefficiencies. Right, these problems can be solved. This is through implementing the economic order quantity, so it reduces time spent on receipting and putting stock away. So the more time can be allocated to cycle counts and to improve the overall inventory accuracy. So what I'm getting at from there is that there's parts that maybe like cheap electrical tape or screws and bolts that are not worth much at all. But we might be doing 20 orders a year. So it's not just that the order cost, because a lot of that stuff is on automatic order, but it's the cost because someone has to get it off the truck, someone has to unpack it, someone has to receipt it, someone has to go and put it away 20 times a year. And economically, that's not the point. So it can bring, save you time, and you can spend that time working on other aspects of the warehouse. So lead times, not accurate. That's not a problem because, as I've mentioned several times, we use the actual POs and receipts to calculate that lead time. Inventory value keeps going up. So forecasting with the artificial intelligence improves safety stock allocation, which results in better service level and parts availability. And adherence to a monthly review cycle will ensure min-maxes are accurate and the excess surplus will be run down. So again, lead times, also having accurate lead times. So if you've got lower, more accurate lead times, you don't have to hold as much stock. So that's the end of the presentation. So I hope you enjoyed it. Thank you very much.